Good morning, dear students, and welcome back to video lessons. In our previous videos, we have discussed about pH and the significance of pH. We also have discussed about physical chemical properties of acids and bases. Today we'll start with the study of salts. In chemistry, salts are ionic compounds that result from neutralization reaction of an acid and a base. These are composed of related number of cations, positively charged ions, and anions, negatively charged ions, so that the product is electrically neutral without a net charge. If we will consider an example here, sodium chloride is the common salt. It is a salt which has been formed by hydrochloric acid and sodium hydroxide. It is having a sodium atom and is having sodium ion and also an atom of chlorine, that is chloride ion. Positive and negative charges are equal. That is why the product is electrically neutral. A few examples of formation of salts are given here. Hydrochloric acid reacts with sodium hydroxide, gives sodium chloride, water. Similarly, hydrobromic acid reacts with potassium hydroxide to give potassium bromide and water. The neutralization reactions are always involved with release of heat. Hence, are the example of exothermic reactions or exothermic change. Naming of salts. A salt is always made when an acid is neutralized by a base. But the exact salt formed depends upon which acid and base were used. The name of a salt usually has two parts. The first part comes from the metal which is present in the base, and the second part comes from the acid that is part of neutralization reaction. Salts have a first name and a last name. First name comes from the metal of the base. Last name comes from the acid involved in the neutralization reaction. So, if the acid is hydrochloric acid, in the neutralization reaction, salt formed will be chloride. If the acid is sulfuric acid, salt formed will be sulfate. If the acid involved is nitric acid, the salt produced will be nitrate. Similarly, if the base is sodium hydroxide, the first name of the salt will be sodium. So sodium hydroxide, when reacts with hydrochloric acid, will give sodium chloride. Sodium hydroxide, when reacts with sulfuric acid, will give sodium sulfate. And sodium hydroxide, when reacts with nitric acid, will give sodium nitrate. Another example is hydrochloric acid reacts with potassium hydroxide to give water and potassium chloride. The acid will dissociate as H plus ion and chloride ion. The base will dissociate as potassium ion and hydroxide ion. Because of exchange of ions, we will have the potassium ion combining with chloride ion forming the salt potassium chloride, and hydrogen ion combining with hydroxide ion forming water. Ionization occurs during neutralization reaction. Since equal ions but oppositely charged present in the salt, hence it is electrically neutral. Salts dissociate only in water. These consist of tightly bonded ions. In water, these bonds are weakened and the ions become mobile. This accounts for the fact that solutions are generally electrolytes. In water, for example, sodium chloride ionizes or dissociates like sodium ion and chloride ion. Salts may also react with water. Now, about the taste. Different salts can have different tastes, odor, depending upon the acid and base which makes up the salt. The salt may have different odors. It also exists different colors. Like for example, sodium chloride is transparent, but potassium dichromate is orange in color. Properties. Apart from these, the special properties of salts are: in the physical form, the salts are crystalline solid. Salts are hard and brittle due to strong ionic bond formed throughout the crystal. Salts also have high melting and boiling points. Salts dissolve in water into free-moving ions and able to conduct electricity. Something that conducts electricity in solution is called an electrolyte. Molten salts also conduct electricity, but solid salts do not conduct electricity as ions are not free to carry the electric flow. A few common examples of salts are sodium chloride, represented by the chemical formula NaCl, magnesium sulfate, MgSO4, potassium iodide, Ki, copper sulfate, CuSO4, calcium chloride, CaCl2, potassium permanganate, KMnO4, sodium acetate, CH3, COONA, calcium acetate, CH3COO whole 2, Ca. Now, when salt is dissolved in water, a solution which is either acidic or basic is formed. The reaction of a salt with water to form acidic or basic solution is known as hydrolysis of salts. So, the salts dissolved in water solution that are not neutral can be acidic or alkaline. The solution of a salt of strong acid and a weak base will be acidic, while a salt of a weak acid and a strong base definitely will be alkaline. Like for example, the salt ammonium chloride, when dissolves in water, gives ammonium hydroxide and hydrochloric acid. Since hydrochloric acid is a strong acid, the solution in water will be acidic in nature. Copper sulfate, when dissolves in water, gives copper hydroxide and sulfuric acid. Again, sulfuric acid is a strong acid. In solution, the particular salt will be acidic. When sodium carbonate dissolves in water, it gives sodium hydroxide and carbonic acid. Here, the base is strong. Hence, the solution will be alkaline. Fourth example of potassium carbonate, when dissolves in water, gives potassium hydroxide and carbonic acid. Again, the acid is a weak acid, whereas the base is a strong, hence the solution will be alkaline. Preparation of salts. Hydrolysis of salt, which is when salts dissolve in water, the reaction involves formation of acidic or basic solution. Hydrolysis involves the split of water molecules into its ions, hydrogen ion and hydroxide. These ions then get attracted to the opposite ions of the salt. The degree of attraction determines which ion, that is, hydrogen ion or hydroxide ion, will be more in the solution, thereby resulting in the solution being acidic with more hydrogen ion in the solution, or basic with more hydroxide ion in the solution, or can be equal concentration of hydrogen ion and hydroxide ion in the solution as neutral solution. The nature of the resultant solutions depends on the nature of the salts. Salt from the strong acids and strong bases are neutral salts. These salts give neutral solution, like for example, hydrolysis of sodium chloride, where H plus ion and hydroxide ions are attracted to equally these ions, that is chloride ion and sodium ion respectively, to form hydrochloric acid and sodium hydroxide. Since the solution contains equal concentration of H plus ion and OH ions, hence it's a neutral solution. Salt is neutral salt. Salts formed from strong acids and weak base, like for example ammonium chloride. Solution of this salt will be acidic, that is, concentration of H plus ion is more than that of hydroxide ion. The hydroxide ions are attracted more to the positive ions of the salt than the H plus ions are attracted to the negative ions. This results in solution being acidic. Salts from the weak acids and strong bases, like for example sodium hydrogen carbonate, formed by sodium hydroxide and carbonic acid, or sodium carbonate salt, formed by again sodium hydroxide and carbonic acid. The solutions are basic, where the concentration of hydroxide ions is more than that of H plus ions. It will attract more H plus ions to the negative ions of the salt than hydroxide ions attracted to the positive ions of the salt. Salts formed from weak acids and weak bases, like for example ammonium carbonate. The solution of this salt will be again neutral, as equal attraction between the positive ions of the salt and hydrogen and hydroxide ions of water. Thus, we can say salts can be of three types: neutral salt, which will have pH equals to 7, like for example, sodium chloride and potassium sulfate, will have hydrochloric acid and sodium hydroxide, and sulfuric acid and potassium hydroxide respectively. The salt can be acidic, which will be having pH less than 7. It will be formed by strong acid and weak base. Like for example, hydrochloric acid reacts with ammonium hydroxide and gives ammonium chloride. Nitric acid, on the other hand, when reacts with magnesium hydroxide, gives magnesium nitrate. Salt can be basic too, where the pH will be more than 7. It is formed by weak acid and strong base. Like for example, carbonic acid when reacts with sodium hydroxide gives sodium carbonate, or acetic acid when reacts with potassium hydroxide gives potassium acetate. Another example can be acidic salt, ammonium chloride, basic salt, sodium carbonate, neutral salt, potassium sulfate, and sodium chloride. Apart from neutralization reaction, salts can also commonly formed by reaction of metals with dilute mineral acids. Like for example, magnesium when reacts with hydrochloric acid gives magnesium chloride along with evolution of hydrogen gas. Similarly, zinc when reacts with hydrochloric acid gives zinc chloride along with the release of hydrogen gas. Magnesium chloride and zinc chloride are salts. The metals when react with sulfuric acid gives sulfates. Like for example, magnesium sulfate and zinc sulfate along with the release of hydrogen gas. The chlorides and sulfates are salts. Family of salts. The salts having the same positive ions, cations, or same negative ions, anions are said to belong to a family of salts. Like for example, sodium chloride, sodium sulfate, sodium carbonate, sodium acetate belong to the same family of salts called sodium salts. These do have same cations, that is sodium ion. Example 2. Sodium chloride, potassium chloride, barium chloride, magnesium chloride, calcium chloride belong to the same family of salts called chloride salts. On dissociation in water, that is hydrolysis of salts, these will give the common and same negative ion, that is chloride ion. Some important families of salt therefore are sodium salts, calcium salts, magnesium salts, potassium salts, aluminium salts, copper salts, ammonium salts, chloride salts, sulfate salts, carbonate salts, nitrate salts, acetate salts, etc. Another characteristic of salts include its water of crystallization. This can be defined as the definite amount of water that the salt chemically combine with when they are formed. Such salts are hydrated salts. These hydrated salts, when heated, give off their respective water of crystallization and by so doing become anhydrous salt. The crystalline shape is because of the hydrated salt. When hydrated, they are crystalline in shape, but when heated, the water of crystallization is released and there is loss of crystalline shape. Few examples of salt with water of crystallization are sodium trioxosulfate decahydrate, Na2SO3.10H2O, iron 2 tetroxosulfate heptahydrate, FeSO4.7H2O, sodium trioxocarbonate decahydrate, Na2CO3.10H2O. The salts can also be called as sodium sulfite decahydrate. Deca here means 10. 10 molecules of water is present, so the salt is decahydrate. The second salt can also be called as iron sulfate heptahydrate. Hepta is for 7. 7 molecules of water is present with iron sulfate, hence it is known as also iron sulfate heptahydrate. Third one, sodium carbonate decahydrate. Deca again is for 10 molecules of water present with the salt sodium carbonate, hence is the example of hydrated salt named as sodium carbonate decahydrate. Copper sulfate pentahydrate, zinc sulfate heptahydrate are another examples of salts with water of crystallization present as 5 molecules of water and 7 molecules of water respectively. Uses of salts. These salts are commonly in use in our daily life, like for example ammonium chloride in torch batteries, ammonium nitrate as in fertilizers, calcium chloride as drying agent, iron sulfate in iron tablets, magnesium sulfate in medicine, potassium nitrate in gunpowder, silver bromide in photography, sodium chloride making sodium hydroxide as well as preservatives, sodium stearate in making soaps. Sodium chloride also is used for seasoning and preserving food, and it is essential for life processes. Sodium bicarbonate is used in baking powder and in manufacturing of glass. Ammonium chloride is used in soldering as an electrolyte in dry cells. Calcium chloride is used as a drying agent to absorb moisture and in freezing mixtures. Silver bromide in making photographic film. Potassium nitrate is used in manufacturing of explosives as well as fertilizers, and sodium nitrate is used in making fertilizers, is a source of nitric acid. So, with salts, we have studied that salts are ionic compounds that result from neutralization reaction of an acid and a base. These are composed of related number of cations and anions so that the product is electrically neutral. Many chemical compounds may be classified as salt. The most familiar to all of us is table salt or common salt. In general, salts are ionic compounds that are having two parts composed of metallic ion and non-metallic ion. Salts can be considered to be formed by reaction of an acid and a base, also reaction of metals with dilute acids. Salts are classified into neutral, basic, or acidic according to the effect they have on pH when dissolved in water. On dissolution in water, the solutions give us neutral solution, basic solution, acidic solution, and this is known as hydrolysis of salts. So, this much we have studied with the general properties of salts and common characteristics of salt. In our next class, we will start with a few examples of salt, their properties, preparations, and uses. Thank you.